So unfortunately, you can't all be in class with me, but this is pretty much what it would look like. I'd be wearing a white robe, staring longingly into a distillation flask, and you'd be somewhere behind me taking notes very quickly, just to hopefully record all the brilliant things that I said. Yeah, that wasn't actually going to happen ever. But I did want to introduce you to a little bit of what makes chemistry the best science, and that's not just my opinion. That's of course a fact. That's what we're going to be studying today. And I just wanted to introduce you to a couple of characters that were really important in my childhood. One was Uncle Fester here. Incidentally, my wife tells me that these are the three emotions that I'm capable of. And so they're all pictured here. Another individual that had a lot to do with why I became a chemist, and this is not actually a lie, was Beaker the Muppet. So if you want to check out why Beaker's so cool, you can go ahead and check out this link. So what we're going to do today is just a real brief introduction to what a chemist studies, and then we'll introduce two pretty important ideas, and that is the idea of a chemical and physical property versus a chemical and physical change. So here are a couple of definitions. Keep in mind what the heck a chemist studies, and really they study matter, which is basically everything you can think of that is an energy. And also, as a part of chemistry, we also study the properties. We're going to define a property as something that is used to identify a bit of matter, and also the changes it undergoes. And there's kind of a more specific text definition, which is a chemist is going to study the composition and properties and interactions of matter. It's pretty much the same darn thing. So just so that we can start the first couple of videos off in the right way and getting a pretty good idea of the so a couple of vocabulary words, matter is defined as anything that has mass and also has volume. One thing that you're gonna hear me refer to quite often in the first couple of weeks here is this idea of density, and you probably have heard about density before. I have a little example via a demo that I'm going to show you in just a second here, but it's defined as the amount of mass in a given amount of volume. So in the example that you're going to see, there's going to be a couple of different items of matter that occupy the same volume but have vastly different masses. And much like back in the days of the dictionary, when you'd look up one definition and there'd be a bunch of words you didn't know in that particular definition and have to look those up too, we also have to define, well, what the heck is mass? Well, there's a much more scientific way of defining it, but I really think about mass as really the junk in the trunk, to be totally inappropriate about it, but it's really the amount of stuff that's in a sample of matter. And I'm going to kind of leave it at that until we talk a little bit about atomic structure, and you can kind of see what the stuff is that I'm talking about in a given sample of matter. And then, of course, you're probably not going to be surprised that volume really measures the amount of space that something occupies. So in other words, I have a bigger volume than one of my kids, for instance. Here we have before us 4 different types of matter. So being matter, they all occupy space and have mass. And so this is just kind of the setup of a demo that I used to do in class. There's kind of 2 different versions of this particular demo. First of all, it's important that you recognize that matter comes in different phases. This is pretty obviously. Both of these bits of matter are in the liquid phase. These 2 bits of matter are in the solid phase. You'll notice that each pair contains just about the same amount of liquid, and these 2 solids are just about the same amount of space occupied. In other words, their volumes are just about the same. The thing that's really different from these 2 things is if you try to pick up this bottle, it's very, very easy to pick up, and that's because it's water. This particular bottle is really hard to pick up. And I don't know any real good way to show you this, but in class I used to find the biggest, toughest looking guy, and I would give them this container to hold, and inevitably they'd either drop it on the ground or have trouble holding it, and then I'd find like the wimpiest person in class that I could find to give this to, and it would be pretty obvious that they had a
no problem carrying that, and so I would just use that as a way to insult the big guy that could probably beat me up. So anyway, here you obviously can't feel how heavy these things are. So what I did was I grabbed the little balance out of your lab kit, and hopefully you'll be able to kind of read the numbers that are associated here. So these both contain different amounts of mass. Keep in mind that mass is kind of the junk in the trunk. It's the amount of stuff that you can actually pick, kind of pack into a given area here. So that guy is about 113 grams. This guy is so incredibly heavy it actually makes the scale malfunction. So I should mention that concept of density, that is a really important physical property, is pretty different here. Water is right around 1 gram per cubic centimeter, whereas this, you can see written on there possibly, is about 13.53 grams per cubic centimeter. So what that means is that there are a lot more atoms, really, or there's a lot more mass in this guy than there is in this guy. It's actually untrue what I said about atoms, but when we start to talk about atomic structure, we'll find out, how do you get so much more matter into this guy, or so much more mass out of that same volume of matter of this guy relative to that guy. Another really fun demo that I used to like to do is we have what looks like 2 rocks, but you'll notice that the amount of mass, or the stuff contained them, is very different. That one's around 42.4. This guy, I don't think it'll make the scale malfunction as long as I don't destroy the scale. Is about 530 grams. And so what I used to famously do with this is I'd carry both of these rocks kind of in front of the front row, and I'd pretend to trip. And of course, this guy, who weighs basically nothing, it's just like a little scrunchy guy, would make people in the front row dive out of the way. And of course, if I had done it with that guy, probably would have killed somebody. No more lawsuits, please.
This idea that all matter has properties, right? These are things that we can use to identify a bit of matter. And there's really 2 different major divisions between us talking about properties, especially in a chemistry class. You're going to hear me quite often refer to this idea of physical properties. And so it's important that we get a definition for this. By the way, keep in mind that I have a resource guide that's available underneath where you found this lecture that kind of helps to organize some of these definitions, especially when you go to take the exam or something. It's just really nice to be able to have all these definitions in one place. But the one thing about physical properties is that you can, they are all characteristics you can use to identify the substance. And importantly, you cannot change the chemical identity of the substance in kind of testing a physical property. Really common examples of things that are physical properties, in other words, things that you don't change the chemical identity by testing a bit of matter, are things like this, right? And so you kind of notice that all of these different things, some you probably recognize, some you might not, but you'll certainly understand it as this class goes on. Well, melting point, right? It turns out that if we have like an ice cube or something and we melt it, like it's still water, right? Just because it's turned into a liquid. It's kind of this idea of a physical property. These are the things that just kind of change, kind of the look of something, or you're changing something behind, the way the substance appears. You're not actually changing the actual way that those atoms are bonded together. Here are just a couple of really common ones. Obviously, density's on there. That's kind of like the big physical property to talk about, given the fact that chemists really, it's their whole point of existence, is to study the amount of mass and the amount of space that something occupies. And it's kind of a central theme there. All the rest of these, one that may kind of be surprising to you is this idea of solubility. So it turns out the fact that, let's say, sodium chloride or table salt dissolves in water is actually an example of a physical property. Associated with this idea of physical, you can also have a physical change, right? And kind of going with that theme of physical in general here is that really there's no change in the chemical identity of a substance when a physical change occurs. So we've got an example of that melting ice cube. That's a great example of a physical change. And when we talk about phases in day 2, tomorrow, you'll see a whole bunch more on this.
And I just had to include a cutting the cheese picture because I guess I'm a cheese ball. Different examples of physical change. I'll just kind of, notice that pretty much anytime you try to identify a physical property of something, you're going to probably see a physical change, right? So, for instance, dissolving one substance in another is considered a physical change. Um, uh, and so these physical changes and physical properties are contrasted with this idea of chemical properties. This is where things get a lot more exciting because when you test a chemical property, you actually change the chemical identity of that original substance. You'll notice there's a very important word in this very next slide, this idea of chemical properties. Reaction, 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 decomposition, right? And also the ability to not react is an example of a chemical property. So as you might guess, there's also this idea of chemical change, right? And so when you do a chemical change, you actually change the chemical identity of a substance. And this is really where you get like the wow factor in class, where, here's an example of a penny, and you combine it with some sort of acid, and then a bunch of orange stuff starts bubbling out that you really don't want anywhere near you, and then the penny turns blue, right? This is a pretty obvious example of a chemical change. Anytime you look at something and kind of go, wow, almost always it's some sort of chemical change that we're seeing, because a lot of these changes are actually, huge changes in the way that this thing is kind of bonded. Here's just a really quick example of something called the particle theory of matter. And so you can kind of see what's happening in this Hindenburg disaster here is that the hydrogen gas, those two little white spheres, got together with two little red spheres called oxygen. And here we've got this little Mickey Mouse molecule called water. But the actual change is associated with a huge amount of energy as you kind of change the bonding environment of these guys, right? It's no longer just hydrogen gas and oxygen gas. You've actually created an entirely new substance here known as water, and along the way, everything else ignites. So examples of chemical changes right here. They're often when you see bubbling or some sort of drastic change in color. Got to be a little careful about color though, because there are some physical changes that are just color changes. But anytime you see fire or combustion, that's always an example of something actually changing the way that it's bonded together on a chemical level. Rotting, change in smell. Oh boy, this is a one way to end a presentation. Rusting or scaling, and the sound of hissing, right? Basically, if you imagine yourself in lab and you're standing there and you see or hear anything that makes you go, ah, that's probably a chemical change. Okay, everybody, I'm going to leave it here, and I'll come back at you tomorrow with a whole bunch of more slides talking about the classification of matter and also the three main phases. And we'll probably also have a little bit of a lecture having to do with this whole particle theory of matter that we saw a little bit in the last slide.